Hi everyone, myself Maria Felicit. Okay, the topic we are going to discuss is vector calculus. So what is vector? Vector is a measurement or a quantity that has both the size and direction. Vector calculus is concerned with differentiation and integration of vector field. Primarily in three-dimensional Euclidean space. So we use this in three-dimensional or also two-dimensional, but basically we use this in three-dimensional Euclidean space. So different types of vectors are defined and various operations can be performed on these vectors, such as addition of two vectors, subtraction of two vectors, product of two vectors, and so on. So here we are going to see the cross product of two vectors. So we are going to see the cross product of two vectors. Okay, the product of two vectors is a method of multiplication of two vectors. So I am going to take a two vectors as A vector and B vector, the two vectors. We are going to use the method of multiplication of two vectors, and it is denoted by the sign into, that is cross. Okay. The vector product of two vectors, A vector and B vector, it is denoted as A vector cross B vector. Here the vector product is also called as another name by cross product. So that is A vector cross B vector. Okay, now the magnitude of the area of the parallelogram. If you see, this is a parallelogram. So we are going to calculate the magnitude of this parallelogram. For this magnitude, how do you calculate? Theta is the angle between. I am going to take a theta is the angle between the two vector A vector and the B vector. Okay. So the cross product of the vector is given by. So for the magnitude, what do you do? The cross product of the vector, how do you calculate this magnitude? A vector cross B vector as AB sin theta. Okay. So here if you see, the angle between the vector is always 90 degree. If you see, the vector angle between A vector and the B vector is 90 degree. That is orthogonal to each other. Okay, A vector and B vector are orthogonal. The cross product is mostly used to determine the vectors. So which is perpendicular to the plane surface spanned by the vector. Okay. Two vectors. So you can find, so if you see here, A vector is perpendicular to B vector, and A vector is perpendicular to A vector cross B vector, and B vector is perpendicular to A vector cross B vector. So here the angle is always, what is this? 90 degree. Okay. So if you see the next one, we can find the direction of the unit vector with the help of the right hand rule. What is the right hand rule? If you stretch our right hand such that the index finger of the right hand in the direction of the first vector and the middle finger is in the direction of the second vector, and the thumb of the right hand indicates the direction or the unit vector. Usually we say the unit vector as n vector. Okay. Next, if you see this, the order is very important in the cross product. So if the vector is, if the order is from A to B, then we have to write it as A vector cross B vector. If the order is from B vector to A vector, then we have to write it as B vector cross A vector. So the order is different here. Okay, if you see the order is from A to B, then you have to write it as A vector and B vector. And if it is from B to A, then you have to say that B vector cross A vector. Okay, the geometrical interpretation. We will move to the geometrical interpretation. First we have told that it is in the parallelogram, area of the parallelogram, it is formed from by the two vectors, A vectors and B vector. If you see this, A and B are perpendicular to each other and it is have the angle as 90 degree. That is always 90 degree. So if you find this magnitude of this parallelogram, magnitude will be A vector modulus of A vector cross B vector will be equal to AB sin theta. So theta here is always 90 degree. Okay, so that is orthogonal to each other. Next, if you move to the properties of cross product, what are the properties? Here, with the help of the right hand rule, we can easily say that the cross product is not commutative. So the right hand rule is A vector cross B vector, but another one is B vector cross A vector. So it is not commutative. So A vector cross B vector is not equal to B vector cross A vector. And here distributive law also holds for cross product. That is A vector cross of B vector plus C vector equal to A vector cross B vector plus A vector cross C vector. And third one is the multiplication by a scalar quantity. So multiplication by a scalar quantity. If you say a scalar quantity can be whatever it may be, a number or some variables or some other things. So here we are going to take it as m of the two vectors, A vector cross B vector equal to scalar of the A vector cross B vector, or you can write it as A vector cross scalar of B vector, or we can write it as A vector cross B vector into the scalar. So the scalar product is that is a scalar quantity satisfies. That is in vector cross product. Okay. We have already know that. Then next case is if A vector and B vector are 0. If A vector, the cross product of the two vectors is 0. If the cross product of the two vector is 0, and we are going to take the A vector and B vector are not null vectors. Okay, so they are not a null vectors. Then when does this two vector cross product of the two vector will be 0? If it is parallel only, then the two vectors will be 0. So we are going to take here, if A vector and B vector are parallel to each other, then A vector cross B vector will be 0. So what is the magnitude? How do you write this magnitude? So modulus of A vector cross B vector equal to AB sin theta. Here the angle is 0. So what is this? It is 0. A vector cross B vector is 0. Then the angle theta will be also 0. Okay. So we already know that a unit vector, that is a directions. So unit vector, I vector, J vector and K vector are the unit vectors in the direction of x-axis, y-axis, z-axis respectively. If two vectors are parallel to each other or parallel to each other or opposite to each other, then the cross product of the two vectors will be 0. So if in the first case, if you see this, I vector cross I vector, it is parallel to each other. J vector cross J vector and K vector cross K vector are parallel to each other. So the angle here is 0, and so the value is equal to 0 vector. If you see, if the two vectors are perpendicular to each other, okay, then it is equal to the product of their magnitude, the other sides of the angle. Okay, if I vector cross J vector equal to the product of the two vectors equal to other thing, that is the angle is 90 degree, perpendicular na it is 90 degree and parallel it is 0 degree. Okay, so perpendicular to each other, I vector cross J vector equal to K vector and J vector cross K vector equal to I vector and K vector cross I vector equal to J vector. So if you say in the reverse, that is a direction opposite directions. If you see this, J vector cross I vector equal to minus K vector and K vector, that is order is very important here now. So first the order is I vector cross J vector equal to K, but here the order is J vector cross I vector equal to minus K. And the previous one, if you see this, J vector cross K vector equal to I vector, the order of the reverse order is K vector cross J vector equal to minus I. And K vector cross I vector equal to J vector, the reverse order is I vector cross K vector equal to minus J vector. Okay. Let us move to the vector component products, vector, that is cross product of the components, that is vector component. So I am going to take A vector and B vector, the two vectors, and crossing these two vectors. So the component of A vector is A1 I vector plus A2 J vector plus A3 K vector. With the directions I am going to write it. And the components of B vector I am going to write it as B1 I vector plus B2 J vector plus B3 K vector. So we are going to take the cross product of these two vectors, A vector and B vector. First I am going to take with the I vector. So cross product of I vector. A1 I vector cross of B1 I vector plus B2 J vector plus B3 K vector. Plus next one I am going to take with the J vector, that is A2 J vector cross of B1 I vector plus B2 J vector plus B3 K vector. And A plus A3 K vector cross product of B1 I vector plus B2 J vector plus B3 K vector. So what we get? That is cross product I am going to take. So A1 B1 of I1 cross I vector, then plus A1 B2 I cross J vector, A1 B3 I cross K vector plus A2 B1 J cross I vector plus A2 B2 J cross J vector plus A2 B3 J cross K vector plus A3 B1 K cross I vector plus A3 B2 K vector cross J vector plus A3 B3 K vector cross K vector. We know that if it is parallel, it is a 0 vector. So if I vector cross I vector is parallel, so it is 0. And J vector cross J vector is 0. K vector cross K vector is 0. Now perpendicular vectors, I vector cross J vector is K. Then J vector cross K vector is I. Okay. So the reverse, that is a cross product. If a cross product order, if the reverse order is there, then it is a minus of the other vector. Okay. So if you see this, finally we will get A vector cross B vector as like this: A2 B3 minus A3 B2 I vector plus A3 B1 minus A1 B3 J vector plus A1 B2 minus A2 B1 K vector. So finally we are the cross product of the two components of vectors, that is A vector cross B vector, we will get the answer. So if you move to an example, okay, so if I am giving two vectors, that is let us take A vector as 5i minus j plus 2k vector and B vector as 2i plus 3j minus k vector. Okay, so if you say if these two vectors are perpendicular, then we have to calculate cross product. Okay, so cross product, if you do, the answer will be minus 5i vector plus 9j vector plus 17 k vector. So dot product is used to find the angle between the two vectors or the length of the vectors. So if A vector and B vector are parallel, then we have to do it as dot product. So dot product, if you do 5i minus j plus 2k vector dot of minus 5i plus 9j plus 17k vector. So we get this has to be equal to 0. Okay, so if it is perpendicular, perpendicular, we have to say this is cross product of the two vectors. Next, finally, another one example. Determine a vector, unit vector perpendicular to the plane of A vector as 5i minus j plus 2k vector and B as 2i plus 3j minus k vector. So perpendicular, what do we do? Cross product once again. So A vector cross B vector, if you do this, answer will be minus 5i plus 9j plus 17k vector, and we have to calculate the magnitude. So magnitude is modulus of A vector cross B vector as root of 25, that is 5 square plus 9 square plus 17 square. We will get it as root of 25 plus 81 plus 289, that is equal to root of 395. Okay, what is unit vector? Unit vector, if you say this unit vector as simply we are going to divide the vector by its magnitude, that's all. Okay, so what is this vector here? A vector cross B vector divided by its magnitude. What is this? Modulus of A vector cross B vector. So finally we get the answer as minus 5i plus 9j plus 17k vector divided by root of 395. So this is a vector. Okay, next class we will see with the other topic. Thank you for listening to this lecture.